right, left, up, down. So there you have it. So here we have the Dungeon Crawler character movement from our series in 2020, and now we've reconstructed it with a component-based system. Welcome back to Arcade. I am Super Tommy, and in this video we're going to look at adding player-based or player movement using a component-based system. So we've looked at a component pattern in a couple of videos ago. So we've added this video for using the component pattern to better structure and organize code and behavior and logic for your games. So we did a swipe gesture video recently, but that is a very specific use case. So for a more common use case, that's of course character movement and character logic. So we're actually going to take, and so I had a demo going on here, but let me refresh this. So you saw briefly there the Faune character from our Dungeon Crawler series. So you can find that Dungeon Crawler series from our Arcade YouTube channel in the playlist tab. So this is the full playlist with the 8.5 videos that go over creating a top-down Dungeon Crawler game in a slightly older version of Phaser, but the concepts are still good there. And so in that video, we created this Faune character as like a top-down Zelda type character, and she can move up, down, left, and right, and have different animations based on that, and we use the keyboard to move her around. So we did it in a relatively basic update loop in the scene. So now in this video, we're going to use a component pattern to compose her behavior. So that's the keyboard movement, and then changing animations depending on which way they're facing or moving, to create the same exact logic by using components. Now, if you want more of this game development content, then be sure to hit like and hit subscribe so you don't miss any videos on game development on the web. So now let's start. I'm going to shrink myself here, go to the corner, and let's go to our demo here. So our Faune character, I've already gotten some files in this project. That's this faune.png. So this is an atlas. So there's a bunch of different animations here. There's moving to the side. I think there's a feint, moving up and down. These are the same atlas we use in the Dungeon Crawler series. And so there's a JSON file describing the frames for the atlas. So we're going to load this atlas. We're going to create the animations, and then we're going to use components to add that movement logic. So let's go to our Hello World scene. We're just going to leave this in the Hello World scene. This is not a full-on project. This is just to show you how to use components to create character movement. So first thing, let's just load our this.load.atlas, and we're going to load to keep Faune. Now it's very possible I'm still not pronouncing this name correct. So assets faune.png, that's the texture URL. And then assets for the atlas URL is faune.json. Atlas's URL wants the JSON file that describes the texture. Great. Now let's just test this real fast. This add.sprite, I just added at 100 using this texture. So we should get one frame there. If it refreshed, let's just manually refresh. Let's see, this add.sprite, that looks good, that looks good. Let's just restart my server in case. So that's running. Let's just make sure we didn't do anything wrong. This.add.sprite, that looks good. There we go. Sometimes just gotta reload your dev server. So we've got this one frame here. Cool. So in our Dungeon Crawler, of course, this is a physics object. So let's actually go player and do this.physics.add.sprite. Put that the same 100, same key. Let's see what we get. Okay, good. So of course I can use the keyboard and nothing happens. Right. Okay. Because I don't have that set up yet. So first I just make some animations and make sure they're all working. Now in that Dungeon Crawler series, it was an older version of Phaser, and while those the code for the making animations in that video are still valid, you can now put animations on sprites specifically. And in this case, that seems to make sense. The player is not going to share their animations with anyone, at least not in this case. Although I suppose if you had like a shadow link situation, you could maybe share the same animations and just tint the textures. But let's just assume we're only going to be used, the animations for Faune only going to be used by the player game object here. So what we do is we can do player.anims.create. So we're going to create animations local to this sprite. And key, just call this run side. That frames will be player.anims.generate frame names. And then this key is the key of the Alice, so that's Faune. And then there's a whole bunch of other config properties. So it's the starting frame, which is 1, the end frame, in our case is 8. There will be a prefix and a suffix. Scroll this up. So prefix, suffix. So in our case, the prefix is going to be basically run-side-. So what this generate frame names will do is fill in the numbers or count the numbers 1 to 8, and then combine it with the prefix and the suffix. And in this case, suffix is .png, and we know that because it's this, the number, which is going to be dynamically filled in, and then the suffix .png. So this is going to be run side. Let's give it a frame rate. Frame rate, let's say 10, and then we want it to repeat forever. So now that's good. Of course, it's not playing yet. Now we do player.play. We do run side. We should see it animate, and there it is. So that is the animation code. Now you would have to do one for each of the directions. So let's just put it in a create player animations method here. And we'll just, in this case, pass in the player, which is a phaser.physics.arcade.sprite. And let's just copy this. We're going to do the rest of them in that method. This dot create player animations, passing in the player game object. Okay. So let's just copy this. So we have run side. Now our animation also has run up and down. You can watch that Dungeon Crawler series for a deeper dive into this, but it's basically the same. We have up, down, side, and they're all frames 1 to 8. And then we want down, basically the same. Instead of side or up, we use down. Also 1 to 8. And now we also want an idle. So let's say we have an idle side. Now we're going to be sure to keep this naming heuristic for these keys like this with the state, the dash, and then the direction. So we talked about this in the Dungeon Crawler series as well, but later you'll see how this is useful when we do the animation changing. Let's just copy this. I want all of this. We're going to want 4 idols, 3 different idols for each direction she can face, because when she stops moving right, for example, and then she stops, it's got to be idle facing right. And same thing for left, up, and down. Okay, so frame here, key Faune frame. This is the frame name. So in this case, we're going to use run side 3. We're just going to use one of the frames in our run animation. Now you may have an actual animation in your game or whatever project you're doing. This may be different. Just in this specific project, we're basically reusing the atlas we have to create an idle animation out of our run animations and our run side up and down animations. So this is idle up, and this goes up. We actually don't need a frame rate and repeat since it's only 1 frame. And lastly, let's do down. And we're just going to assume the third frame is good. All right, let's just give it a quick test here. So let's run side. Let's go run up. Good. Run down. Good. Idle down. Just say that's good. I don't think her arms are out. Is it? Up. Okay. Side. Okay, good. I think that's good. Okay. So now we have our player game object. It's a arcade physics sprite. We create the animations and we can play it. This is where the fun part starts. We can add components to handle the movement and the animation switching. So in our Dungeon Crawler series, you'll know that we did our character animation, or character movement here in this update loop for the scene. And that is totally fine. You could definitely do that, and we've done that in many videos that you've seen here. But instead, we're going to create components that we can compose so that you can add different logics and behavior together to create interesting effects in your game, interesting mechanics in your game. So one thing to go over is our component service. Now, we created this component service a few videos ago, and we've already set this up in the scene, where what we've done is created a component service in init, and then we call update the component service update in the scene's update loop. So that now our component service is set up to give us update in our components, awake, start, and destroy. If we want to do destroy, we'll have to do this, this.events.on in the scene. So when the scene is shut down, so phaser.scenes.events.shutdown, we will actually want to also do this.components.destroy just to clean up after ourselves. That's the basic setup for our component service in the scene. So now to actually make some components, first thing we'll do, I already have a folder for components. We're going to make a keyboard movement component. So keyboard movement.ts. So now this is going to be the arrow keys for movement. So of course our character uses this, but you can also use it for any other game object. And you can just add this component to that game object and it'll automatically or automatically respond to keyboard controls to move it up, down, left, right. So let's show you how we do that. So let's import Phaser. From Phaser, we're going to need that, just at least for some types. And let's go export default class keyboard movement. Keyboard movement, let's just collapse this. And then I'm going to implement the iComponent interface from our component service. So just do that. And our iComponent interface expects at least this init method, phaser.gameObjects.gameObject. So let's just look at our iComponent we just defined here. So yes, so in our original video, we did not have this optional components passed into init, but we have it now here. We're not going to need it in this video, but this is what this comment is. But you can see there's a init that we definitely need, and then there's this awake, start, update, and destroy, which are optional. So if we implement them in our component, they will be called. If we don't, they will be ignored. And so with this setup, we can create basically any logic or behavior that we want. So here in our keyboard movement, let's actually just save a reference to our game object. And in this case, we actually know that we want to deal with physics sprites, since we want to set the velocity when we move our character. So this.gameObject go. TypeScript will complain that game object does not, all the properties are not necessarily on game object that are in arcade physics sprite, but that's okay because we know we're going to get a physics sprite. Doke. All right, so that's good. Now in update, so now we're going to define an update. That means update will get called for this component. we are going to, based on our cursor keys, which we need, so we're going to, in our constructor, take in some cursor keys. So that's phaser dot types dot input dot keyboard dot cursor keys, and private read only cursors. Let's just take this type. I want to type this out again. No, not repeat. Read only. Okay. This dot cursors. So we're going to be given our cursor keys in the constructor, which we'll create later. So now inside this component, we can just assume we have it and we'll use it. And so we're just going to go if this dot cursors dot left dot is down. We're going to want to move our game object left. So this dot game object dot set velocity x some amount, and that some amount we can actually make configurable by also taking it in as a constructor parameter. Speed, give this number. Then we gave it a default speed of 100 in the parameter here. And so now let's go minus this dot speed. And then for right, we can do velocity x plus speed. And then that down, let's go up. That is down. It's going to be y, and up is negative y. And then this dot cursors dot down, that is down. But y, but this time positive. And then if we're not moving at all, so none of the keys are down, this dot game object dot set velocity 0, 0. So we just stop. Now, in our Dungeon Crawler series, we did make sure that our character can only move up or down, or left or right, but not both. So you can't go diagonal. So just to mimic that, set velocity y. So when you're moving left or right, you are not moving up or down. And if you're moving up or down, you are not moving left or right. That's how we do it here. The same thing as in the Dungeon Crawler video series. So that should be it for this keyboard movement component. Now you can see it's pretty simple. It's a very small class. It's 50 lines, not even. We have spaces here. So this is much easier to reason about. I think you can probably tell, and you can see it only does one thing. It only does keyboard movement to whatever game object this is attached to. So that's already looking pretty cool. Now to use it, let's go back to our scene here. And let's go to, let's do this. This dot components dot add component, which will take in a game object, so in this case player, and a new movement keyboard movement component, which needs cursor keys, which we don't have yet. Let's just change that. So we also need cursor keys. So let's make some in our scene here. Phaser.types.input.keyboard.cursor keys. Let's go in init this dot input.keyboard.create cursor keys. So now those are our cursor keys created 1%. And then we're gonna compare this dot cursors. I'll leave the speed at 100. Now, by adding this component, we should be able to move our character now. So let's see. And we can. Look at that. So you can perhaps see the composability and reusability of this component. It's not in a big class, right? You don't have to like go fishing in a giant class or base class for it. That component always stays that small. Nothing else really will be added to it. And it can be reused on any other game object you want. Now, of course, we're not done yet. Because in this example here, our character has no animations. They don't switch. We're stuck at idle here. So let's add another component that handles animations. Now, of course, we could do it in the keyboard movement here, right? Obviously, we can just go this.gameObject.play run side, for example. And that would be okay. but that of course makes this component less generic and less reusable across the board. So instead, let's make another component. I'm just going to call it animation on input. If you have a better name, feel free to use it. Import phaser from phaser. Then let's say export default class animation on input implements I component, and we'll let that auto import it for us. Okay, let's collapse this. So now this component is going to be only responsible in it for handling or changing animation based on your cursor keys. Is it no game object? Oops, game object dot game object. Let's get rid of this semicolon. Private game object, and let's see. We want the most common base class. So I think in this case, all we need is a sprite. So this .game object go as phaser.gameObjects.sprite so that it can work on any game object that is of type sprite, physics sprite, normal sprite, matter sprite, or arcade sprite, matter sprite, whatever sprite. Or if you have a subclass of sprite, your own sprite, whatever it might be. Okay, so we have that. We also want cursor keys here. Constructor cursors phaser.types.input.keyboard cursor keys. And here, let's also make this read-only of the same type. Okay, this dot cursors. Okay, and let's give it an update here. And then if this dot cursors dot left dot is down. Now, to make this generic, we can't just say run side, because a different animation or different atlas, different character may have different animation sets. So we ideally want this given to us, like what exactly is going to be the animation to play when left key is down. So let's pass that into the constructor, and we're going to make a new type here, animation data. Let's say left, and what we're going to want is a key, which is the animation key. And then we're going to say whether you should flip it or not. That's optional, but it's a Boolean. Now data, animation data. So whenever we make one of these components, we'll get this information in the constructor. So private read-only data phaser dot animation phaser, no, just animation data. And this dot data. And so what we're going to do here, so this dot game object dot play, this dot data dot left dot key. So we're going to play the key for sure. And now, if whether we should flip that animation or not, we can do this dot game object dot set flip x, this dot data dot left dot flip. And there's no texture complaints because it could be undefined or Boolean, right? But set flip x only wants a Boolean, so we can use this bang bang or double exclamation mark to basically turn a falsy or truthy value in JavaScript into a Boolean true or false value. So let's just test this with left is down and this one key for left. Let's go to our scene. Here we're going to do this dot components dot add component to our player new animation on input. I'm going to use the same cursor keys and then a little bit more information, this animation data. So animation data key we're going to do is run side. We know that. And flip, I think flip true. Yeah, because this is looking right. So flip true. And now if we press left, we play the left running animation, but of course not right up or down since we did not implement that. Let's finish this off by implementing that. So here we know this is going to take the same thing, and then up takes the same thing, And down takes the same thing. Well, one more, which is going to be none. So when no keys are pressed, what should play? Okay, good. So else if this dot cursors dot right dot is down, and we'll just take this because it's basically the same, except instead of left, it is right. Same thing for flip. Now for let's say up dot is down. This is basically the same, except it's up. And this is up for the flip. So you could also do, I'll do it for the next one. Just give you another way to write this code. Down dot is down. You can do key flip. You can do some object destructuring here. Dot data dot down. And then I don't know if it's any that much better, but key. And then this will be flip. Yeah, those are the options. Maybe you'll like it better. I don't know, but there's another way to do it. All right, else, last one. This is for the none case where no keys are pressed. Now this is where it gets a little less generic, but you can add a flag in this property here. We're not going to do it in this video, but just as a thought exercise to use like useStrict or compose false or something like that, whatever key you may want to add for it not to auto-generate the idle keys or to like construct the idle keys for you. As we know in our specific case here, we're going to want basically, if we're facing left, if we're doing a run side, idle needs to be idle side. If we're walking down, idle will have to be idle down. So we do that. Let's get the direction. This dot GameObject dot anims dot current animation that's currently playing dot key. I'm going to split that by the dash, which is what we talked about earlier in this video about how we're naming these animations. In a heuristic, that's the same. 1. So it was, run dash side and then idle dash side. So in this case, we split run dash side by dash. We get an array. Index 0 is run. Index 1 is side. So we're going to take index 1. That's our direction. And then we're going to do this.GameObject.play. And we're going to do, so it's action first. So in this case, this dot data dot none dot key. We're going to take the key passed in dash direction, and then let's just say this ignore if playing is true for everyone. Actually, one there, one there, one there. Go back to our scene. Now we need to actually fill this in for everyone. So that was right. So key is run up for up. There's no flipping. Down is key run dash down. And then none is idle. Okay. And there we go. Right, left, up, down. So there you have it. So here we have the dungeon crawler character movement from our series in 2020. And now we've reconstructed it with a component-based system. So you see, we just add these two components to any old physics sprite, and we can give it a keyboard movement and animation change based on the key presses. So this is the nice part of components. You can just mix and match different behavior, different components together to create different behaviors or effects so that your game is a bit more interesting and more easier to structure your code and to create different interactions that you may want in your game without having to copy code around or deal with a complex inheritance tree. All our components, and you can see here, this is a 50-line class. And we are not even trying to save line space. This animation and input is itself a 60-line class, right? These are small files, easy to reason about, easy to read, and all we do is compose them together by adding the components to this game object, and we have our functionality. So that's it for this video. If you enjoyed what you saw, do hit like and hit subscribe and possibly hit that notification bell so you can be notified the next time we have another component-based video coming out. Now we're going to do a bunch of these videos, so be sure to hit subscribe and hit that bell so that you don't miss any of these videos.